Hey everybody, this is Ruster Metro Game Core. Today we're going to review an external GPU. This one is called the GPD G1. And this little guy is many things in one. It's a Thunderbolt or USB hub, and then of course is an external GPU with a Radeon RX 7600M XT inside. And probably one of the best features about it is that it has multiple different ways to connect. In addition to its high-speed Oculink connection, it can also do USB 4, Thunderbolt 3, and Thunderbolt 4. So chances are if you have a handheld or mini PC that supports any of those connectivity options, you can actually use this thing here. And as you'll see in this video, it will increase your gaming performance significantly. Anyway, I've been wanting to test this thing for months now, so without any further delay, let's go ahead and jump in. Okay, to start, this is a review unit sent over to me from DroiX. And I've mentioned them a few times before, but they're an online reseller out of the UK. And as full disclosure, no money was exchanged in any way, I'm not using any affiliate links down below, and of course they're not seeing this ahead of time. Now there's a few things I like about DroiX, so let's talk about that real quick. Number one, they have a variety of different products, all of the things that are kind of near and dear to my heart. In addition to having a variety of mini PCs from various different brands, they also carry a lot of handheld PCs, those of the Neo, 1X Player, and GPD variety. And I've always found this to be a pretty big deal because these handheld PC companies will often move on to the next product and then not sell the old ones anymore. And the nice thing about DroiX is that they will keep having them in stock. They've also got a pretty good selection of different retro handhelds, including those from Anbernic and Retroid and even the Miyoo Mini Plus. And then of course they've got a variety of accessories, including the docking station we'll be taking a look at here today. Now there's two other things I like to say when I talk about this company is number one, yes, some of the prices are sometimes a little bit higher than if you buy them direct or from AliExpress, but often that price will actually be in favor of the buyer. For example, because they ship out of the UK, if you're in the UK or in Europe, you might actually find a better deal here just because of the various import taxes. So the final price here might vary a lot depending on the region you live in. Another thing to keep in mind is that because they have that ongoing stock, they will often put them on sale. So this is a good way to buy a handheld or mini PC that might be a little bit older, but still at a decent price. Now, other than the price, two other things I like to mention about DroiX are that one, they have a knowledge base, so this is going to be an independent website. And within here, you'll find a bunch of different articles related to the various platforms that they support. And they've also got things like buying guides to let you figure out which one's going to be the best fit for you. And so this goes into the other part I like to talk about with these guys, in that they have a very good customer support service. In addition to all of these topics that they have here, it's actually very easy to get a hold of them to troubleshoot any problems you might have. For example, on the front page, you can just click on Contact Us, and they've got an email address, and they say that they will answer it within a few hours during working hours or within 24 hours if it's a weekend. In addition, they do have live chat as well. And so this is kind of one of the things that really makes DroiX stand out to me and why I even want to talk about them in the first place. Because yes, even though sometimes the prices might be a little bit more than if you get them on Indiegogo or directly from AliExpress, you're going to get a much better experience. Not only will they vet and test all of the devices they send out to everyone, but then they'll also support you afterwards as well. And if you've ever bought one of these devices from those Chinese companies, you know that support is kind of lacking. Anyway, I think that's enough gushing about how much I like this company. Let's move over to the GPD G1. Now, if you were to buy it directly from GPD, like on their AliExpress, it's about $700, and as you can see here, it's $740. And so there definitely is a price difference, but again, be on the lookout for sales and whatnot. Either way, some of the most important aspects of the GPD G1 is the fact that it does have that Radeon RX 7600M XT GPU, which is a mid-range mobile GPU which came out earlier this year. Now, it might not look like it, but there's also a 240 watt GaN power supply within this dock as well. And it is also capable of giving power delivery from the USB-C port up to 60 watts. And so that's really kind of it when it comes to the main specs. Let's move on to the unboxing. First thing, let's take a look inside the accessories box, and you see that it comes with the GPD instruction manual that'll walk you through all the connectivity options you have with this device. And there's some variety here. For example, you can use just the USB 4 connection or just the Oculink or both of them to get the best of both worlds. Of note, if you only use the Oculink connection, it's not going to give you access to the USB ports. So I do recommend plugging in both if you have those connection options. Anyway, also in the box, we get a full speed Thunderbolt 4 cable. And this is capable of 40 gigabytes per second connection and 240 watts of power. And then other than that, it's just the power cable. Like I mentioned, the power supply is in the dock itself. Speaking of which, let's take a look at the dock. Now the top here is metal, and it has a nice kind of rib design to it. Also up top, you can see there's the circle with the fan intake vent. Other than that, it looks a lot like some other Thunderbolt docks that I've seen previously. Let's go ahead and take a look at the back connectivity. On the far left, we have the power supply input, and then we have 3 USB-A 3.2 Gen 2 ports. After that, we have an SD card reader for expanded storage, and then 2 DisplayPort 1.4a ports. And then finally on the far right, we have an HDMI 2.1 port. Now on the front, we have a power button to turn the GPU on, and then we have our USB-C cable capable of USB 4, Thunderbolt 3, and 4. And then finally in the center, we also have that Oculink port, which is still kind of new and really only used in certain devices, but I've got a couple that I can show off here in this video. Now on the left side, these grates here are the exhaust vent, and it will blow out some pretty hot air. And then finally on the bottom, not much to see here other than just 4 rubber feet to keep it in place. Now, in addition to the GPU, GPD also sells a case, which I happen to get as well, and I think this retails for something like $30. And I'm not really sure whether or not this will be a great fit for you, but maybe if you're traveling a lot, this might be a good solution. Either way, it does have a magnetic clasp to kind of hold it in place, and yeah, it looks pretty good. Now, in terms of size, here's a comparison against the ROG Ally. And so as you can see here, it's about the size of a mid-range handheld. In terms of weight, we're looking at 851 grams, which is a little bit under 2 pounds, and it's a little over 200 grams heavier than the ROG Ally. In all, I think that's a pretty lightweight size considering the fact that it's both a power supply and a GPU. Now for the rest of the video, I'm going to do a bunch of testing, both benchmarks and then real-world gaming experiences, and I'm also going to use different handhelds and various mini PCs with different connection options. However, for the most part, my standard baseline is going to be the GPD Win Mini. And this is a device I reviewed about a month or two ago, and it's super tiny, and so I think it's a really nice combination with this external GPU. Anyway, in addition to testing it with the GPU, I'm going to test it without it as well. So let me give you a quick rundown of this setup so we know what we're starting with here in our baseline. So here you can see I'm using a Ugreen Steam Deck dock connected to the back of the Win Mini. Then I've got a bunch of ports connected. We'll start from the bottom and work our way from the top. So to start, I have a 65-watt power cable plugged in. Then we have our HDMI output and Ethernet cable, and then a USB-A 2.4 GHz for my mouse, and then a USB-C connection to my solid-state drive, which is loaded up with a bunch of PC games. And then finally at the very top with the yellow is my 2.4 GHz dongle for my controller. And so all that's connected to the Win Mini right now and kind of in a docked fashion. And then from there, I'm plugging it into my 24-inch Asus monitor, which is 1080p but 144 Hz. And so to start, we're going to do a bunch of benchmarking just so we can see some numbers and see how they compare between the different hookups. And to start, we're just going to do the docked experience like we just showed. And for all these tests, I'll be running the 3D Mark TimeSpy gaming benchmark. And so here are the results just from the PC alone. And don't worry about memorizing the numbers, I'll put them all together at one point. Either way, you can see that the TimeSpy score for the Win Mini at its max TDP of 25 watts is a little bit under 3000. So next we're going to do the exact same test but with the GPD G1. And the Win Mini is capable of connecting either through USB 4 or through Oculink, so we'll test each of those. And we'll start with USB 4, so I'm going to move over all my dongles into the GPD dock, and then I'm going to connect it with the Thunderbolt cable that came with the GPD G1. And really that's it. It's a one cable solution here if you want to use it with Thunderbolt 3, 4, or USB 4. Now to get everything to work, you want to plug this in while everything is powered off, and then press the power button on the GPD G1. After that, you want to wait a second and then start up your computer. Now with any luck, it should just detect it automatically, especially if you have the latest AMD drivers installed. However, sometimes I did find with the USB-C connection, I did have to power off the G1 and then power it back on before it got recognized. Anyway, that's one of the nice things about the Thunderbolt connection here is that it is hot swappable, so you can just turn this on and off as needed. Either way, now that we're all connected up, let's go ahead and run the same benchmark. And here's a look at the results, a little bit over 9,000 with the TimeSpy score. And so here's a comparison between the two. And from a raw numbers perspective, you can see that the CPU score is about the same, a little bit better when it's plugged into the dock. But the graphics score is much higher. In fact, it's over 3 times higher compared to not using the GPD G1. So from a pure numbers perspective, when playing GPU-centric games, we're looking at 3 times better in terms of performance. And of course, we'll do a bunch of real-world testing here later to see what that actually is going to mean when playing a game. Now next we're going to do the Oculink, and here it's actually the exact same hookup, but you're going to add the Oculink cable as well. And you also want to do that same power on process. Now like I mentioned, there's not a lot of devices that actually have Oculink support, and most of them are actually GPD devices right now, including the Win Mini. Anyway, one thing I did find that when connecting up Oculink is that it did detect my monitor right off the bat first time. And so when it comes to just pure connectivity, I found the Oculink to actually work better than the USB-C connection. Either way, let's go ahead and run the same benchmark and and look at our scores. And you can see here that the score here is even better, but I was surprised to find that it's not a ton better than the USB-C connection. So let's go ahead and take a look at all three of these now combined. So on the top left, we have the score of just the Win Mini itself, just connected to the monitor directly. And then on the top right, we have the Thunderbolt 4 connection using that USB-C cable. And then finally down below, we have our Oculink connection. And you can see that the CPU score is about the same between the two when it comes to the GPD G1, but the graphics score is higher on the Oculink, and that's because it has a higher bandwidth of data transfer. And so as a result, there's less of a bottleneck coming from the GPU. And essentially that is why we're getting a better score. Now the difference between 9000 and 9300 is kind of negligible, but all the same, if you're looking for the best performance possible and you do have an Oculink connection with whatever device you're using, then it's definitely in your interest to use the Oculink cable. Now I also tested this out on a bunch of other devices, including like the iNeo 2S, which has the same Ryzen 7840U chipset inside, but it doesn't have Oculink, so we're only using the USB 4 connection. But as you can see, the score is about the same as the Win Mini when connected to USB-C, so any of these devices are going to work great. I also did the same connection, but with the GPD Win Max 2, which also has an Oculink connection. And the results here are similar to the Win Mini with the Oculink, but a little bit higher. And I think part of that probably has to do with the fact that the Win Max 2 is not limited to a 25 watt TDP. Now finally, another device I want to show a demonstration with is the Beelink SCR7. This is a mini PC using the Ryzen 7840HS chip, which is very similar to the 7840U we were just looking at. And this one also only has a USB 4 connection, so no Oculink. However, because it is a desktop mini PC, it does have a much higher TDP, and so as a result here you can see that its raw score is higher than the others, but that's because it's clocked at something like a 54 watt TDP. And so that's why you can see the CPU score is actually a lot higher, which pushes up the overall TimeSpy score. And so I want to use this mini PC for a bunch of other tests, including with the GPD G1. And so to start, we're going to connect it to the GPD G1, but like I mentioned before, it doesn't have Oculink, so we're just going to use USB-C. And here's the score, which again is higher than the other handhelds, but I think a lot of this has to do with that TDP. And like with the others, don't worry about memorizing these numbers, we'll compare them all side by side here in a moment. Now, in addition to testing it against the GPD G1, I wanted to use another external GPU. And I happen to own this one here. It is called the Razer Chroma X. And I've showed this thing off a couple times in other videos before. In fact, I planned on making a video about it at one point, but I gotta say that I'm not a huge fan of this thing, and there's a few reasons for it. Number one, this thing is expensive. In fact, the price is kind of outrageous. It's about $500 on Amazon, and it's at the same price if you order it directly from Razer. And bear in mind that this $500 only gets you the enclosure and the power supply. You still need to bring your own GPU. The second thing that bothers me about this one is that it's only Thunderbolt 3, which is a pretty low standard of connectivity. And unfortunately, because that has a pretty low bandwidth when it comes to data transfer, you will be bottlenecked depending on the GPU that you use. Now, the main draw of the Razer Chroma X is the fact that you can use a full desktop class GPU. So right here's an example. Here's an RTX 3070 Ti. And I actually bought this GPU for about $300, $350 specifically for this eGPU to make for a video. And here's a look at the rest of everything else. Here's the power supply as well as an additional cooling fan. And then on the back, you can see you have direct access to your GPU. And then it also includes 4 USB-A ports and an Ethernet port. Anyway, before we get into the actual testing with this eGPU, I just wanted to do a quick size comparison between the G1 and the Razer Chroma X. And of course, it's kind of comical how different these are in terms of size. And I think between the two, it'll really come down to what your priorities are. If you need something that's very small, but you don't mind being limited to just the one GPU that's inside the G1, then obviously that's going to make a lot of sense. However, if you have a spare desktop GPU, it might make more sense to get the Razer Chroma X. Either way, let's jump into testing. Now, my plan here was to use the 3070 Ti, but I gotta say that after about 2 days straight of testing and trying to install this on various devices, I ran into so many problems. And a lot of it is not the result of the Razer Chroma or even the mini PCs or handheld PCs that I tried testing it with. What it really comes down to is compatibility issues between AMD and NVIDIA GPU drivers. So for example, when trying to install the GeForce Experience or the GPU drivers directly, every single device I tried them on using a 7840U chipset would crash. And it's no exaggeration to say that I tried this on like 5 or 6 different mini PCs and handhelds and had the same result every time. So at the end of the day, I actually had to abandon my plans to use the RTX 3070 Ti, and I ended up pulling out my AMD GPU from my old desktop PC. This one here is the AMD Radeon RX 6650 XT, And thankfully there were no connection issues whatsoever. As long as I had the latest AMD drivers with Adrenalin, everything connected just fine. So long story short, this is going to be the baseline that we're going to use to compare against the GPD G1. And so as a result, let's do a quick comparison against the desktop GPU here and the mobile GPU that's installed inside of the GPD one. So here's a look at the desktop 6650 XT. Now there's three things we're going to measure right here as our comparison. Number one is going to be the compute units for the GPU, and as you can see here, it is 32. Another thing we'll look at is what AMD calls the game frequency. And this is the clock speed that they expect most games to play at when running with this GPU. So keep this number in mind, about 2400 megahertz or 2.4 gigahertz. And then finally, I want to look at the power draw. You can see that the board power is going to be about 180 watts, which is quite a bit more than the mobile GPU, which we'll now look at. So here are the specs of the one that's inside the GPD G1. This is the RX 7600M XT. And you're going to see that the numbers are pretty similar. This one also has 32 compute units, and the game frequency is a little bit lower. It's 2300 megahertz instead of 24. Either way, I think that is pretty close considering the fact that we're comparing a mobile and a desktop GPU, which is kind of hard to do. In addition, you can see the GPU power maxes out at 120 watts. And of note, the GPD G1 comes configured up to just 100 watts. You can change that by reflashing the firmware, but as it stands, I tested it at the standard 100 watts, and you can go higher, although it will increase the fan noise. Speaking of which, before we get into our actual testing, let's test out the fan noise on the GPD G1 so you can get an idea of how loud it's going to be. And I have to say, when it comes to the overall noise level, I would say it's a little bit less than a gaming laptop, but it is quite loud. So even at 100 watts, it is something that I would consider to be a bit on the loud spectrum, but still a lot less loud than something like a gaming laptop or a full desktop. Anyway, now that we have all that out of the way, let's now move over to the testing with the Razer Chroma GPU. And bearing in mind this is only a Thunderbolt 3 connection, here are the results. And as you can see, it's a little bit shy of that 9,000 score that we got previously with the GPD G1. And of course, my assumption here is the bottleneck is happening because of that Thunderbolt 3 connection. But of course, I always like to be thorough, so let's actually test that. I'm going to put it back into my old PC, and we're going to run that same benchmark again. Now, this isn't an apples to apples comparison because we do have a different CPU inside of this machine, and this is an older Ryzen 7 3700X, which honestly is kind of a mid-tier CPU from a few years back. And so the performance here is actually probably a little bit worse than the 7840U and HS that we're testing here today. Either way, because this is a GPU intensive test, I'm not too worried about it because it's really going to be focusing on the GPU performance. And so here are the results with that desktop class 6650 XT GPU inside of a full PC. And you can see it is well over 9,000, so there is a big difference here between the two. And as promised, here is a comparison of all four at once so we can really get into the nitty-gritty about these numbers. So starting up on the top left, this is the Beelink SCR7 just connected directly into a monitor with no external GPU. And you can see the score here is pretty good. We got over 3,000. And of note, the CPU score is actually pretty darn high. It's 10,600. And like I mentioned before, a lot of this can be attributed to the fact that this is running at a higher wattage DDP. Now on the top right, we have the GPD G1 with that mobile GPU and connected via that Thunderbolt 4 cable. Here you can see that the CPU score is still really high, but in addition, we have a much higher graphics score as well, over 9,000. Now on the bottom left, we have the Razer Chroma X, and this is using that Thunderbolt 3 connection. And here you can see the CPU score is about the same, which makes sense again because that's not being bottlenecked. But you can see the graphics score is about 8,500, giving us a score overall of under 9,000. And then finally on the right, we have our full desktop class experience. So this is going to be my B450 motherboard with the Ryzen 7 3600X, and then of course that same desktop GPU. And there's a couple things to note. The CPU score is actually lower than it was on the 7840HS within the Beelink. And again, that makes sense. This is an older CPU. However, there's a big jump when it comes to the graphics score, about a 10% increase. And again, this is because the GPU is connected directly onto the motherboard, so there is no Thunderbolt 3 bottleneck. Either way, what I find interesting is that the GPD G1 on the top right has a very similar score to the full desktop with the 6650 XT. Of course, the CPU score is different and the GPU score is a little bit better on the desktop, but all the same, it kind of washes out. But in the end, the performance here with the Beelink and GPD G1 combination is about the same as a full desktop experience, which I paid maybe about $1,300 for a couple years back. So I realize that's a lot of numbers and figures here, but I hope that gives you an idea of what you can expect depending on whatever connectivity option you're using if you do have a GPD G1. And how that's really going to stack up when it comes to an external GPU option like the Razer Chroma X, or even a mid-tier or a little bit older desktop PC. Now next, before we get into game testing, let's talk a little bit about pricing. Like I mentioned before, the GPD G1 is going to be about $740. And then also bear in mind that the test case we're using, the Beelink SCR7 mini PC, goes for about $600, maybe $650 right now. Either way, for our GPU solution, it's about $740 for the GPD G1. And then the Razer Chroma is actually a pretty similar price when you combine the Chroma X itself as well as the same GPU. Now this one I bought for about $300, maybe $350 last year, but I just looked earlier on Amazon and you can get them for about $250 right now. So really when it comes down to it, the configurations that we're comparing against are priced about the same. They're both going to cost you about $750 at the end of the day. And of course, there's good and bad for each side. The GPD G1 is much smaller and also consumes less power, but the Chroma X is going to allow you to add any desktop class GPU. However, that does assume you are able to install the GPU drivers and actually get it to work. Anyway, now that we've gone through this whole numbers rabbit hole, let's move over now and talk about actual game performance. And we're going to do a series of 3 different examples using the GPD Win Mini as our test case. So to start, here is just the GPD Win Mini itself plugged into my monitor, and we're running at the max TDP allowable on this device, which is 25 watts. And here you can see I'm running Doom Eternal at 1080p with medium settings, and we're getting an average of about 65 frames per second. That's actually not bad. And also bear in mind for all these, I'm turning off VSync so we can get the highest frame rate possible, so you might see some screen tearing. Either way, for this example, I would probably set it to a VSync and 60 frames per second lock. And I'd say that's actually a pretty good time. You know, being able to plug in the Win Mini like this into a monitor and playing a full-scale game like this is pretty incredible. At least when you think of it in the context of having a very small PC like this. But one thing to bear in mind is that even at the 25 watt TDP limit, the Win Mini gets really hot. You can see the GPU temperature is about 85 degrees altogether. Now, as we plug in the GPD G1, let me go over a couple different things. Number one, we'll talk about the fact that the G1 sometimes does not get picked up by certain games, at least in the beginning. So for example, here with God of War, even though it is running with the GPD G1, it's still putting all the power into the integrated graphics. That's why you can see the GPU temperature now is over 90 degrees because it's trying to push all the way. Thankfully, it's a pretty easy fix here within many of these games. You often just have to go into the display settings and there will be an option about what GPU you're going to use. And so here I'm going to change it from the default 7080M integrated graphics over to the RX 7600M XT in the GPD G1. After that, you likely have to restart the game, but here we are. Now you can see that the GPU temperatures are much lower, around 65 degrees, and all that power is now going into the GPD G1. Even here at the title screen, you can see it's pulling a full 90 watts. Now we are going to test God of War here in a moment, but I want to go back to Doom Eternal. If you remember, on its own, it was getting about 65 or 70 frames per second at 1080p medium. But here we are with the GPD G1 connected only over Thunderbolt, and we're running it at 1080p Ultra, so not the very highest settings, which are Ultra Nightmare, but honestly, I can't tell the difference between Ultra and Ultra Nightmare, so that's what I'm going to use here. Either way, you can see that the frame rate is hovering around 165 frames per second. So not only did we increase the graphical fidelity by a bunch, but we also improved the frame rate by almost 3 times. So here we're seeing a huge increase in performance just using that USB 4 connection. And for me, this also demonstrates one other use case. If you have a mini PC or handheld PC that only has a USB 4 connection, you can expect to see a huge performance increase if you happen to use a GPD G1. Okay, next up, we're going to use those exact same settings, but with an Oculink connection instead. And so here you can see with Ultra settings again, 1080p, we're getting an average frame rate of about 200 frames per second. So here we are seeing a jump between 30 and 40 frames per second between Thunderbolt and Oculink. So again, if you are using a device with an Oculink connection, you'll actually get the best of both worlds. Not only will you have all the connectivity of a USB hub, but you'll also get that faster connection because of that bigger bandwidth. Now, even though my monitor is only a 1080p resolution, there are certain games where you can game it to a higher one. And the Final Fantasy VII Remake is my favorite example. To start, we're just going to use it docked, so no external GPU, and we're going to run it at 1080p with high textures and low shadows. This is generally the settings I prefer to use when playing this game. Now when just kind of walking around, you often will get 60 frames per second pretty stably, but with this game, when you start to jump into combat, you will see the frame rate dip quite a bit. So I would say on average, when in combat at 1080p high-low settings, I would expect about 50 frames per second, maybe 55 depending on the part of the game. But either way, it's definitely not a full 60 frames per second. So next we're going to do Thunderbolt GPD G1, but we're going to up the resolution to 4K and high settings for everything. And same scenario here, when walking around it is going to give you a good 60 frames per second, but when jumping into combat it will dip down here and there. Now thankfully it doesn't dip down as much. I would say the lowest it goes is about maybe 53 frames per second, but I would say maybe the average when in combat is going to be between 55 and 57 frames altogether. So here we're seeing a huge increase in graphical fidelity from 1080p to 4K, but we're also getting a more stable experience than we were at 1080p with just the device itself. And of course, as you can imagine, 1440p gaming is probably going to be that sweet spot between the two. In fact, that is what this GPU is usually billed as being good for, is 1440p. Anyway, moving along now, let's do the Oculink connection with the exact same 4K high settings. And here, as expected, we're getting a stable 60 frames per second when not in combat. But the surprising thing here is that the performance is much better when in combat now that we have Oculink. Now we're still getting a dip here and there. I never saw it go more than like 54 frames per second, and the dips are a lot fewer and further between than before. And so overall, Oculink does give me a much smoother gameplay experience. In fact, I would be more than happy to play this game at 4K with these settings. Okay, moving on, the next test case we're going to use is going to be God of War. We're going to start with 1080p low settings with the device just docked directly into the monitor, and you can see that the average frame rate is about 40 frames per second altogether with this game. It'll definitely go above that, and usually what I will do is just cap it at 40 frames, and that usually will give me the best experience. And again, it's really impressive that we can even play God of War at 1080p with this device over 30 frames. Now, unfortunately, God of War is one of those games where I can't increase the resolution past what the monitor allows. However, there's a huge difference in performance requirements between low and ultra, and so 1080p ultra really does tax the system quite a bit. And here you can see it is pulling that full 100 watts of power, and we're getting a pretty great frame rate. Sometimes we go under 60 frames, but for the most part, it was going to be over. And it really depends on what's going on in the scene, but I would say just as a conservative assessment, about 65 frames per second is going to be the average you can expect here at 1080p Ultra. And again, bear in mind, this is only the USB 4 connection. So now moving over to the Oculink, you can see that the frame rate is quite a bit better. Here I found about a 10 frames per second increase across the board between these two. So really it's not a huge increase in performance, but still being able to play this game at 1080p Ultra is pretty impressive. In fact, I've always found that the Ultra settings are just kind of overkill with God of War. This is a game I prefer to play in high settings because I can't tell the difference with my eyeballs between high and Ultra. And when you swap it over to high settings, it just gets even better. In fact, many times the game would cap out at a full 120 frames per second. So again, as expected, the Oculink performs better than the USB 4, and it is pretty awesome to see such good performance with a AAA game like God of War. Now, in addition, I also tried out some other games, but I didn't do the full suite of testing like we just did with those three, but here are the results of a few more. We'll start with Red Dead Redemption 2. This one I'm playing at 1080p in Ultra settings, and I'm getting an average frame rate of about 80 frames per second. So again, that's really impressive. Next up is Baldur's Gate 3, again with 1080p Ultra settings. I basically turned on every setting that I could with the exception of ray tracing, because that doesn't really work with AMD GPUs very well. Either way, you can see here the average frame rate's about 75 or 80 frames per second with this game. And then finally, I also tested Cyberpunk 2077. This one wasn't so hot with Ultra settings, but I found that high settings looked great and played really well. And here I would say the average is between 65 and 70 frames with this game. And again, this is something I would probably lock to 60 frames per second and just enjoy it like that. By the way, my character is about to get hit with a car and it scared the crap out of me, so let's watch that really quickly. Anyway, yeah, I had this going pretty loudly, so it did scare me a lot. Okay, I'm not really sure what other testing I can really do with this device, so I think it's time to just wrap up and talk about what I like and what I don't like about the GPD G1. And as always, we'll start with what I like, and number one here is going to be the portability. As I showed, this thing is quite small. It's actually smaller than the ROG Ally, and the weight here is not bad. It's less than 2 pounds, considering the fact that it has a GPU and a 240 watt power supply inside. That's pretty crazy. I was also very impressed with the performance. I honestly wasn't expecting it to be as good as it was. Not only did every single game play gameplay at basically the highest settings I could at 1080p, but I think it's going to be really great for a 1440p resolution as well. On top of that, the components stayed nice and cool despite having heavy performance. Even at the highest setting, I never saw the GPD G1 go over 72 degrees Celsius at 100 watts. And I would say probably the biggest strength of the GPD G1 is its versatility. For example, if you've got a mini PC or a handheld that has a USB 4 connection, this is going to instantly improve the performance by a ton. And the thing is, if you happen to buy a different mini PC or a handheld down the line, as long as it has USB 4 or Oculink, you're going to be able to use it on that as well. So I do love the fact that it can be used on multiple devices. And full disclosure, I have the ROG Ally and the XG Mobile GPU. And I do love that one a lot, but all the same, I do get worried about what's going to happen in the future because it has a proprietary connection. With this one, you're covered with multiple bases, not only USB 4, but Thunderbolt 3 and 4 and Oculink. Speaking of which, the other thing I really liked about the GPD G1 is the performance we can get with just the USB 4 or Thunderbolt 4 connection. In fact, the difference between that and Oculink was really kind of within spitting distance. And so it's at the point where I don't think that this is only for people who have Oculink. If you have USB 4, like on a handheld or mini PC, I think this is still going to be a big upgrade. And finally, the other positive idea I had about the GPD G1 is that it also will relieve some of the stress that you can put on your handheld or mini PC. For example, when connecting it to this external GPU, it doesn't get as hot. And additionally, the CPU does not get taxed as much either. In fact, I found on average, the CPU package power was around 11 watts altogether when plugged into the GPD G1. It didn't require the full 25 watts that I set the TDP to. And so I really like this idea that when you plug in a handheld or a mini PC into this external GPU, you're going to get a ton of better performance, but you're also not going to stress out your components. And so it might actually result in increasing the longevity of that device. Now, of course, like with anything, there are quite a few things that I don't like about the GPD G1, so let's talk about those. Number one, even though I love the fact that it's versatile and you can use it with multiple devices, I'm not a huge fan of the fact that the GPU itself is not upgradable. Essentially what you're doing here is you're buying a mobile GPU and then also the power supply all in one. And really that's not a bad thing. I think this is a pretty decent GPU that'll be good for years to come. But all the same, it is very different from that desktop experience, where if you just want to upgrade a single component, you can. And additionally, even though I would consider this probably a mid-tier GPU in the grand scope of things, this is kind of a high-tier price. If you were to spend $750-ish on a GPU on its own, you can definitely get something that has much better performance than the one that we have within the GPD G1. And so again, you're really paying for that overall experience. You're getting the dock as well as the GPU and a power supply in one. And all the same, that price is pretty steep. It's going to be sometimes the same price or higher than the handheld or mini PC you'll be plugging it into. And finally, some other nitpicks that I had have to do with the ports and the placement of those ports. Number one, I like the fact that we have 3 USB-A ports, but it also would have been nice to have an Ethernet port. I think that's probably something that's standard with a lot of Thunderbolt or USB docks, and so it just doesn't make sense to me that they didn't include it. In addition, I'm not a huge fan of the placement of the ports. For example, the front of the dock has only the Thunderbolt and the Oculink connection, but when it comes down to it, those are connections you're probably not going to use very often. In fact, I would rather have them on the back of the device. Instead, on the front, I would love to have just regular old USB connections. That way I can plug in things like keyboard dongles or a controller, things like that. So for me, it just doesn't make a lot of sense on a desktop placement to put those two connections right there, and it does make the entire setup experience just a little bit more cluttered than I would like. Finally, the other thing that you have to bear in mind about the GPD G1 is it doesn't have a smart shutdown like a lot of other eGPUs. When you're done using this setup and you power off your PC, you have to still physically press the power button on the front of the GPD G1. Now, that's not a huge deal, and I bet you will probably get in the habit of it if you own this, but all the same, it would have been really nice if it just shut itself down when it was done. So when it comes down to it, you're probably wondering whether or not I recommend the GPD G1 external GPU. And I would say it comes with a big whopping it depends. Number one, if you already have a mini PC or a handheld PC and you're looking to upgrade, and you're not quite ready to just buy a new computer, this is a really good stopgap measure. Not only that, when you are ready to upgrade to a different handheld PC or mini PC, you'll still have the GPD G1, which will still improve the performance on the new one as well. In addition, I would also recommend this if you are looking for something that's a lot smaller or more portable. And so if those two ideas align to the way that you approach handhelds or mini PCs, then yes, I think it's actually a really good deal. In fact, I can't wait to use this in further testing and just use it on my desktop in the future. That being said, if you already have a desktop GPU that you want to use in like a bigger enclosure, or you have a nice full desktop PC, then probably yeah, this isn't going to be a great fit. However, if you're one of the people like me who are tight on space but still want a desktop class experience without having a full desktop, then I think the GPD G1 is kind of a home run. In fact, it makes me kind of excited about other external GPU solutions that we may see in the future. As it stands right now, this is the only one on the market that has Oculink and Thunderbolt 4. So let me know what you think in the comments down below. Is the price tag enough to warrant that increased performance, or do you think we should wait for something else down the line? As always, thank you for watching, and be sure to like and subscribe if you found this helpful, and we will see you next time. Happy gaming.